Alright friends, this is the third installment on evaluating alternative hypervisors now that Broadcom is making VMware untenable to use for home labs and small to medium businesses. In the last two videos, I focused on XCP&G and Proxmox as alternatives to ESXi. If you haven't seen those videos, check them out. Now it's time to talk about the third most requested hypervisor, and believe it or not, it's Microsoft Hyper-V. Let's get to it. Hey there, home labbers and self-hosters, Rich here. This video is the third video focused on evaluating your options if you're coming from the world of VMware and ESXi, with this video in particular being focused on Microsoft Hyper-V. Again, my background is in VMware, so I'm going to be looking at this from that perspective and giving you my thoughts and opinions along the way. And I'm going to be honest with you all, I am personally not a fan of Microsoft Hyper-V, but I will endeavor to be as open-minded and as fair as I can be. As we always do, I think we should start with some background on Hyper-V and the history of the product first. The origin story of Microsoft Hyper-V began with its initial release on June 26, 2008 as part of an update to Windows Server 2008. It was a significant step for Microsoft, marking its entry into the hardware virtualization space dominated by VMware and Citrix. On October 1, 2008, Microsoft also released Hyper-V Server. Built on Windows Server 2008 Core, this standalone version of Hyper-V was freely available, requiring no software license to operate. With the release of Windows Server 2008 R2, Hyper-V received several enhancements including live migration of VMs, expanded support for operating systems, and improved performance and stability. With the release of Windows Server 2012, Hyper-V saw a major overhaul, introducing features like Hyper-V Replica for disaster recovery, a new virtual hard disk format, and network virtualization. Scalability was also significantly improved, supporting much larger VMs and physical hosts than before. The following year, with the release of Server 2012 R2, Hyper-V saw an introduction of Gen 2 virtual machines, enhanced live migration capabilities, and storage quality of service. With the release of Windows Server 2016 came support for Docker and containers, nested virtualization, and shielded VMs for improved security. Hyper-V also received improvements to its software-defined networking and storage capabilities. Windows Server 2019 brought features focused on cloud and hybrid environments, with Hyper-V gaining integration with Azure, including Azure Backup, Azure File Sync, and the Storage Migration Service. It also introduced Windows Admin Center for easier management of servers, clusters, and hyper-converged infrastructure. 2019 also saw the announcement from Microsoft officially ending the free Hyper-V Server, with the 2019 edition being the final release. Support for Hyper-V Server 2019 will reach the end of support in 2029. The announcement of Hyper-V Server was seen by many as the end of Hyper-V. However, there are no official plans known from Microsoft to allude to the end of Hyper-V as a built-in component of Windows Server. So that's the history of Hyper-V in a nutshell. Since it's always been a feature add-on to Windows Server, it makes sense that its feature enhancements are also tied to each Windows Server release. I have to admit, I didn't even know there was a free standalone version of Hyper-V, and when that announcement came out about its end, I also assumed, like many, that it was the end of Hyper-V itself. Clearly, it is not. Speaking of that, this comparison is not based on the free Hyper-V server, but instead is using Server 2022 and the Hyper-V add-on within. And with that, let's talk about Hyper-V and how it compares to ESXi. Let's start with architecture. Both Microsoft Hyper-V and VMware ESXi are Type 1 hypervisors. However, there are key differences in their deployment methodologies. ESXi is very lightweight by design, only containing a minimum footprint to function, and once booted, runs solely from RAM. All of the VMware ESXi kernel is closed source. Microsoft Hyper-V is a component of Windows Server, and as such is deployed after a complete setup of the Windows Server OS. Because Microsoft offers both a core or GUI-less version of Server and the full desktop experience version of Windows Server, footprints of a Hyper-V deployment can be dramatically different. Hyper-V is also closed source. On to performance. While performance is highly dependent on what's running in your workloads, these days, performance between the two hypervisors looks to be nearly equivalent. Version 8 of ESXi supports a maximum of 896 logical CPUs and up to 24 terabytes of RAM per host. Hyper-V supports up to 512 logical CPUs and a maximum of 48 terabytes of RAM in Server 2022. Now let's talk about usability. Both ESXi and Hyper-V have built-in management GUIs for host and virtual machine management. However, that's where the similarities end. ESXi's embedded web-based HTML5 GUI is solely focused on singular host and virtual machine management, and the extended functionality requires vCenter. In contrast, Hyper-V's built-in management interface is not web-based, and there are a variety of ways a user can administer Hyper-V, but all access must be done from a Windows OS or a PowerShell command line. Hyper-V does support the same host and virtual machine management functionality, but also provides extended features like clustering, live migrations, and backup functionality. Once again, it's tough to compare these two management interfaces together for a few reasons. For one, Hyper-V is more than just a singular host and VM management system. You can certainly just manage those things and a lot more. There is no vCenter equivalent for Hyper-V in terms of additional software. However, you will need to use different management consoles to manage different aspects of Hyper-V. For example, singular host management can be done using the Hyper-V Manager, but cluster management is handled through the Failover Cluster Manager Console, or SCVMM. Let's talk about features next. ESXi and vCenter offer a wide range of advanced features, including distributed resource scheduling, high availability, fault tolerance, vMotion, which is VMware's term for live migration of VMs, storage vMotion, and API control. However, all of these features require additional licensing to unlock. By default, the best you'll get with ESXi is basic VM management out of the box without vCenter. Hyper-V also supports clustering, live workload migrations, live storage migrations, high availability, and workload balancing based on utilization. For the most part, Hyper-V is nearly feature complete with the licensable features of VMware. Now let's talk about scalability. ESXi is very well known for its scalability and is used in some of the largest virtual environments in the world. ESXi is fully capable of managing over 1,000 VMs without issue, and when adding vCenter into the equation, it has the ability to support up to 2,500 virtual hosts with many tens of thousands of VMs, no sweat. Hyper-V also features scaling, and its adoption has been strong in the enterprise space primarily because it's a free feature of the Windows Server platform. Hyper-V natively supports over 1,000 VMs running on a single host, and in terms of clustering, will service and manage up to 64 nodes per cluster with up to 8,000 VMs running. And for the business-minded viewers, let's talk about support. VMware offers extensive professional support, trainings, certifications, an extremely well-maintained public knowledge base, and a large community behind it. That being said, with the changes in Broadcom's new ownership, it's unclear exactly how that will affect product support, access to the KB, and so on. Hyper-V, being an add-on feature to Windows Server, has a variety of support options via Microsoft Support website, community forums, and by contacting Microsoft directly for support. Microsoft does not offer a certification path specifically for Hyper-V. However, there are numerous Windows Server certifications available. And lastly, cost. Here's where the rubber meets the road, and for VMware ESXi, the most recent changes being made to licensing by Broadcom will effectively put VMware out of the reach for most people. It's very likely the reason you're watching this video now. And to add insult to injury, as of February 12, 2024, the VMware ESXi free hypervisor is no longer available. When considering licensing for Hyper-V on Windows Server, your costs are dependent on which version of Windows Server you choose. For Windows Server 2022, the data center version clocks in at $6,155 USD and licenses you to run unlimited Windows VMs in Hyper-V. The standard edition comes in at $1,069 USD and allows you up to 2 licensed Windows VMs. There are no licensing limitations for Linux VMs. And as previously mentioned, you can still download the free Microsoft Hyper-V 2019 server today, which has an end of life in 2029. Alright, overview out of the way here, let's look at some real-world examples of the two side by side, along with my thoughts on both. As I mentioned earlier, there are numerous ways to manage Hyper-V, and I'm going to be using the built-in Hyper-V Manager console. I'm choosing to use the Hyper-V Manager specifically because that's what comes with the default installation of Hyper-V. Yes, I'm aware of Windows Admin Center and SCVMM. Feel free to tell me I'm doing it wrong and which alternative console I should use in the comments. The first stop here is to take a look at both consoles and compare. Here are both consoles side by side, and right away we see a huge disparity between the two. We'll start with the incumbent ESXi. The ESXi console provides some information about the physical host, like ESXi version information, OEM hardware manufacturer, processor type, count and speed, and RAM amount on the host, as well as the URL for web management. In terms of configuration, pressing F2 and logging into the host provides you with very basic management functionality. In essence, the most you can do is configure or change your management interface settings, enable support functionality like enabling SSH or local prompt access, enable lockdown mode, and that's about it. Via F12, you can manage shutting down or rebooting the host itself. Outside of these basic functions, VMware expects anything beyond this to happen from within the built-in HTML5 management web GUI. And in contrast, Hyper-V doesn't have a console. Since Hyper-V doesn't exist without being installed on Windows, your only interaction with it is via the graphical interface of Windows Server, regardless of whether you're running Windows Server Core or with the desktop experience. The disparity between these two is pretty stark, and coming from the world of VMware, I would typically complain about how a console is an absolutely critical component to a hypervisor. And that is still the case, but being is that the console is just Windows, there really is no need for a discrete console for Hyper-V. So let's dig into their respective management GUIs now and the differences between the two. As I mentioned earlier, both systems have a built-in management GUI, but how you access them is radically different. If you watched the last two videos, you can skip to the next timestamp as we'll be showing the same examples of the ESXi Web UI. This is the web management UI of ESXi. Landing on the main dashboard, you're given a summary of all of your host state, usage, vSwitch and port group configs, data stores mounted and free space, system information, and at-a-glance graph of overall CPU and RAM usage on the host. On the bottom in the Recent Tasks pane are all of the active and recent tasks that are running or have occurred. On the left is your navigation pane, where you can dig deeper into your host configuration and monitor your performance, hardware, events, logs, and more. In the Virtual Machine tab, you get a full list of the running VMs on the host, details about storage usage, guest OS config, host name, CPU, and memory usage. When you drill down into a specific VM, you get health, utilization and configuration information, snapshot, and access to the console, as well as all the standard VM management functions like power, suspend, restart, and hardware configuration options. In the Storage tab, you get an at-a-glance view of your mounted data stores, their utilization and type, as well as the ability to create new data stores. Across the top, you view and manage your virtual storage adapters, devices, and so on. When drilling down into a configured data store, you view further information about the storage type, location, host connected, virtual machines connected to it, and with the data store browser at the top, browse the storage system, upload and download data, and otherwise manage the data store as desired. The last tab to touch on the web GUI is the Networking tab. At a glance, you see all of the port groups configured on your host, and drilling down into any of them provides you with detailed information about the port group, VMs connected, vSwitch that serves the group, and a visualization of how the VMs with network interfaces assigned to that port group connect to the physical network. Backing out to the Virtual Switches tab and viewing your configured vSwitches, you get an incredibly rich level of information about all virtual networks on your host, the VMs connected to them, and how they connect to your physical networks. The main networking tab is also where you can view and manage physical network adapters on your host, VM kernel NICs, TCP stacks, and firewall rules. Hyper-V Manager is the GUI interface that installs by default when you install Hyper-V in Windows Server. This GUI is only available on Windows as it's based on the Microsoft Management Console, commonly known as MMC. This console can also be installed on most Windows and server desktops and can remotely connect to a Hyper-V server. The Hyper-V Manager interface shares some general similarities with the ESXi GUI. The left pane is focused on host navigation only and doesn't expand out to any components below. The top pane lists the current VMs deployed in Hyper-V, including their current state, CPU usage, assigned memory, uptime, status, and configuration version. The middle pane is where any snapshots, or in Hyper-V terms, checkpoints, for a VM would appear, and down at the very bottom in the smallest pane, we see actual information about the selected VM, including an absolutely bare-bones summary with a tiny console, a memory tab with basic memory information, a networking tab with basic information about the network of the VM, and a replication tab that would show you information about the replication status of the VM if that was configured. On the right side, we have all of the actions available to Hyper-V. Starting at the top, New allows you to create a virtual machine, hard disk, or floppy disk, and you can import an existing Hyper-V virtual machine using the import function. Next option is Hyper-V Settings, which is where the bulk of the configurations for Hyper-V live. The first option, Virtual Hard Disks, allows you to define where on the file system your host will store the virtual hard disks for your virtual machines. In the Virtual Machines section, you define where on your file system you would like to store the configuration files for your virtual machines. This is a much different approach compared to VMware. VMware by default stores all of the data associated with the VM in its own dedicated folder on the data store, virtual disks, configs, snaps, and everything else. Next is the NUMA spanning option, which allows you to decide if you want to allow VMs with multiple virtual CPUs to span across multiple physical CPUs in your host. It's nice that Hyper-V is NUMA aware and that you have the option to allow NUMA node spanning selectively. In comparison to VMware, the ESXi hypervisor will automatically work to keep workloads in the same NUMA node to prevent any NUMA attacks or performance issues when running VMs. Next is the live migration setting, which allows you, if you have multiple Hyper-V servers, to enable or disable incoming and outgoing live migrations. One thing to note here, this feature is only available for Hyper-V servers that are joined to the same Active Directory domain. Now onto storage migrations. This option allows you to define the number of concurrent storage migrations that can be performed on your Hyper-V server at any given time. It's worth mentioning here that VM storage migrations is something that can be independent of live VM migrations. If you want to move a VM's data to another storage target accessible to your local Hyper-V host, you can do so without having to have a cluster. This is not something you can do in ESXi easily, but it is a feature of vCenter. Enhanced Session Mode Policy enables a more interactive and feature-rich experience when connecting to VMs using Hyper-V Manager. To take advantage of these features, the VM has to support it, and from my research, looks like only Windows VMs do. And now replication configuration. Hyper-V provides a replication mechanism for virtual machines to enhance disaster recovery and business continuity. This section allows you to enable your server as a replica server and configure settings around handling replications. And that's all there is to server settings for Hyper-V. The next section is focused on user interactivity with VM consoles, like managing special keyboard keys, changing the combination to break your mouse free from VMs that aren't virtualization aware, how to handle enhanced session mode for VMs that support it, and lastly, an option to reset checkbox configs across your Hyper-V server, and that's it. From a general host configuration standpoint, Hyper-V is pretty sparse. However, I'm going to cut it some slack here since things like storage configurations and overall host configurations is something that is handled by the Windows OS itself. And Hyper-V just sits on top of that and uses those configurations. There are two additional configuration sections though that are specific to Hyper-V: Virtual Switch Management and Virtual SAN Management, so let's check those out now. Virtual Switch Manager is next. Hyper-V Virtual Switch Manager is where you configure your virtual switches for your host. Hyper-V essentially has three different types of switches. External, which is a virtual switch that connects to a physical network interface on the host, providing VMs assigned to it to have access to the network. Internal, which creates a virtual network between VMs and the host itself. And finally, private, which creates a virtual network between VMs only. It's hard to compare ESXi's vSwitch and port groups to Hyper-V's because there really is no reason for a VM to have access to the underlying host or its management plane. And how your vSwitches and port groups are configured in terms of connectivity is how you define what they have access to. You can see I have a single virtual switch named External Switch already defined on my host. Clicking on that shows you the extent of the configurability and functionality within. I've connected my external switch to a singular network interface on my host. It's worth noting here that you can only select one interface to bind to, not multiples for redundancy. For network redundancy, you need to configure that for the Windows server itself through whatever means are available for your network interface. There's also a subsection to enable or disable switch extensions and prioritize order if needed. And lastly, we have MAC address range, where you can define the entire range of MAC addresses your Hyper-V host provisions for each network-connected VM. I'm not sure why anyone would want the option to change this considering you can really screw things up on your network, but there it is. Big differences here in terms of virtual networking between Hyper-V and ESXi. As previously mentioned, it's clear that Microsoft's approach to providing three options for virtual switches is scoped around hard segmentation zones, which is a fine approach. In contrast, ESXi and even vCenter for that matter are more configurable and flexible, and there's no need for a VM to host only vSwitch. In terms of network redundancy, again, it's a situation of what the Windows Server host is configured for in terms of physical network fault tolerance and redundancy, and Hyper-V just piggybacks off those available NIC configurations. One last thing to mention here in contrast on networking between ESXi and Hyper-V is VLANs. In ESXi, you define the VLAN at the port group level so that when you assign any VM to that port group, they're automatically tagged by the hypervisor for that VLAN. With Hyper-V, that is not the case. VLAN tagging is handled at the virtual NIC level of the VM itself. And lastly, we have the Virtual SAN Manager, which is used for setting up access to fiber channel SANs. And at least as far as I'm seeing, that's all it does. I don't have a fiber channel HBA in my system or a fiber channel SAN in my Homelab, and it's 2024, so iSCSI or bust. You can fight me in the comments. Edit Disk starts a wizard that allows you to select and walk through expanding a virtual machine's virtual disk. Coming from the world of VMware, it's a foreign concept to have a dedicated wizard just to increase disk size, since in VMware, you just pop into the virtual machine's configuration settings and increase the disk to whatever new size you want. Speaking of VM disks, Hyper-V only thin provisions disks when you create virtual disks for your VMs. There's no option for thick provisioning, which these days is fine. Inspect Disks just pops open an Explorer window to all of the collection of virtual disks you have on your host. Again, I'll point out that I find it so strange that Microsoft decided to spread the data of virtual machines around like this. The next set of shortcuts on the left allows you to stop, restart, refresh, and remove the current Hyper-V server from the MMC console, change columns in your Windows, and start Windows Help. And now we're on to the contextual VM actions. From this point, we're affecting or interacting with the selected VM in the top middle pane. Connect will pop open the console for the selected VM and allow you to interact with that VM. One nice thing about the Hyper-V console over ESXi is that the console window in Hyper-V isn't bound to the management GUI like it is in the ESXi web GUI. In Hyper-V, it's a separate window that you can open and minimize, which I find convenient. Settings pops open the configuration settings for the selected VM. For people familiar with virtualization, you get similar virtual hardware options as you do in ESXi. Hyper-V has two generations of VMs, Gen 1 and Gen 2. The differences are numerous, but to put it broadly, Gen 2 has newer hardware features and no legacy hardware. This VM was built as a Gen 1 and has more virtual hardware by default than a Gen 2 VM. You can see hardware like COM ports and a floppy disk drive, as well as the selection of a legacy network adapter, which aren't available in Gen 2 VMs. Gen 1 VMs cannot hot add new hardware, which is why all of the hardware options under Add Hardware are grayed out. Gen 2 VMs can hot add network interfaces, but the rest must be done with the VM off. Gen 1 VMs are also BIOS boot only. UEFI boot is only available under Gen 2. Let's run through this quickly. BIOS allows you to modify boot order for the VM. Security in Gen 1 is deprecated, and in Gen 2 allows you to turn on Trusted Boot and also supports virtual TPMs, something that ESXi does not. In the memory section, you can adjust the total memory provided to a VM, and Hyper-V supports memory hot add. In the processor section, you can define how many virtual cores to assign to a VM, but only cores. You cannot define core and socket count. The compatibility subsection allows you to enable CPU compatibility for the VM. This is similar to VMware's EVC in terms of CPU compatibility for VMs in the cluster. The NUMA section allows you to modify NUMA topology as it pertains specifically to the VM. Hyper-V prefers a virtual IDE controller for Gen 1 VMs, which we see here with the virtual hard disk attached. In Gen 2 VMs, Hyper-V defaults to a virtual SCSI controller for virtual storage. Both generations allow you to hot add new disks to the VM. As mentioned earlier, if you wish to expand the virtual disk of a VM, you must do so using the Edit Disk Wizard on the left pane of the Hyper-V Manager to expand the disk. It's not done within the VM settings. For the network settings, you define which vSwitch your VM is connected to, and you can define what VLAN to have Hyper-V tag its traffic as. Depending on the generation selection of your VM and the type of network adapter chosen, there are additional features like hardware acceleration, which are unavailable to the legacy network adapter. In data management, you can rename your VM and have spaces in the name, which is great. Integration services are services that are made available to the VM from the hypervisor, but the VM must support them to take advantage of them, so basically Windows VMs only. Checkpoints allows you to define where a VM snapshots live and what type of snapshots they are. Hyper-V supports checkpoints with memory like VMware does, but unlike VMware, you can't choose to snap with memory or not at the time you create the snapshot. It's based on the VM settings here. Odd. Smart Paging File Location allows you to define the location of the page or swap file for the VM, again, at a VM level and not at a machine level like VMware ESXi. Automatic Start Action allows you to set the VM to start with the computer, and Automatic Stop Action allows you to define what happens when you shut down the physical server itself. So that's a comparison of the two interfaces. Now I'm going to talk about the things I like, dislike, and the good and the bad, again coming from my VMware ESXi perspective. Feel free to disagree with me in the comments of this video or on our Discord server. Here's where I say to you, after using Hyper-V for X amount of weeks, I can say that it will satisfy your needs as an alternative to ESXi. But I'm not going to do that here. Yes, you can run Hyper-V to run VMs, but not all VMs are created equal in Hyper-V. If you're a Windows shop and you're running only Windows VMs, knock yourself out. Hyper-V has all the compatibility you'll need to run Windows VMs on Windows. Linux is not so lucky. For example, Hyper-V supports most Linux distros, but the devil is in the details. Depending on which Linux distribution you're using, there are varying degrees of support. The website I'm showing you right now runs through the list of what's supported and what's not, and the gotchas of running Linux on Hyper-V. It's up to you to make sure that what you're running is compatible with Hyper-V. It's because of this I can't really say it's a good replacement for ESXi. ESXi doesn't care one bit what I run in a virtual machine. People run macOS all day long on VMware, something that is not supported in Hyper-V. Hell, I have a VM of Haiku, which is an x86 reimaging of BIOS from the 90s, and it happily runs in my cluster and works without any issues because ESXi has compatibility to support it. If your Homelab is focused on experimentation and learning, it doesn't make any sense to use a hypervisor that imposes limitations on the types of OSs it will run. All right, so let's talk about what I don't like, even though it seems like I've already started. Well, let's start with the user experience. Hyper-V Manager suffers from something I call MMC syndrome. What is MMC syndrome, you ask? Well, MMC, or Microsoft Management Console syndrome, is when every management interface on Windows generically looks the same because it's all shoved into the framework of MMC. And the Hyper-V management interface is pure trash. Why would anybody at Microsoft think it's a great way to manage a hypervisor? Where are your overview stats of your host as they pertain to virtualization operations? Not in Hyper-V Manager, that's for sure. Where are the histograms of load and utilization for your VMs? Also not in Hyper-V Manager. What's the actual state of my VMs? Hyper-V Manager says they're running. Why the hell is the console snapshot image for a VM a tiny square on the bottom of the screen? And who at Microsoft thought it would be such a good idea to put all the checkpoint information so prominently in the middle of the Hyper-V Manager? The Hyper-V Manager UI is a masterclass in either not caring about your job as a UI UX engineer, or Microsoft just gives zero f***. I know what you're gonna say. You're gonna say, you're doing it wrong. You should be using Windows Admin Center, or if you're an enterprise, you should be using SCVMM. And you know, you're right. If I did use Hyper-V, I'd be crazy not to because they are better. But in the case of Windows Admin Center, that option didn't come out until Server 2019, and it's not built into Hyper-V as part of the installation. It's an extra application to install, and System Center is an entirely different beast all to itself. How Microsoft could continue to lead with Hyper-V Manager as the default management interface to this day is beyond me. Also, Windows Admin Center only provides you basic virtual machine and virtual switch management. You still have to go to Hyper-V Manager to manage the Hyper-V host, set up or manage clusters, and so on, so it's really only a 50% solution at best. And really, if I'm being honest with you, Hyper-V and its existence as a hypervisor has always felt like Microsoft created it because they didn't want to be left behind during the early years of virtualization. You gotta remember that when Hyper-V arrived on the scene, VMware and Citrix were the darlings of the early days of mass adoption of virtualization in the data center. I've always felt that Hyper-V, for Microsoft at least, as it pertains to on-premise, was an afterthought. I know there are lots of businesses and MSPs that are running Hyper-V, but I believe the choice to do so was always driven by cost decisions, not whether it was a superior product. I have personally met Windows admins who would look me straight in the eye and say, oh, virtualization is virtualization. Hyper-V is fine and it's free. I don't have to pay anything additional for virtualization. And in terms of MSPs, again, it's a cost decision. If you told a business they needed to buy licenses for Windows Server and also virtualization licensing, they're gonna say that's too much. But if it's baked in already and you just pay for Windows licensing, you're gonna be good to go. But ask anyone who uses basically any other modern virtualization platform what they think of Hyper-V, and they'll tell you it sucks, and friends, they're right. And that, friends, will do it for this video. If you liked it, throw us a sub and a like, and if you have a beef with anything I've said here, let me know in the comments below. Special thank you to our YouTube members. You guys help keep the lights on, and we thank you for it. If you'd like to help support the channel, consider becoming a member or buying some of our awesome swag. It all helps us keep making these videos. And now that you finished watching this video, how about checking out this playlist over here of other great self-hosting and Homelab videos we've done in the past. If you're looking for your next great Homelab idea, we can help.